Hello, hello. If you're watching this, you missed day 2 of our week 2 Foundations of Tech class. Let's get started. So you missed quite a bit today, so it's a shame you weren't here, but hopefully we can get you caught up and up to speed. What we are doing is we're starting our electricity unit, one of my very favorite subjects, so I'm very excited to get you into it. We did a short warm-up, which was just a couple of stretches, and then we dove right in. Please don't forget that assignment 1, design challenge, is due tonight by midnight. So if you, for some reason, are watching this on Wednesday the 10th, that is. Now, if you're watching this afterwards, it's already past due. Please make an effort to get this into me so that I don't have to dock you more points and we can all be happy. Please, please, please. All right. Assignment 2, Intro to Power Generation, is going to be due Wednesday the 17th, and we are going to introduce some of the concepts you need in order to do this assignment today. So let's get to it. I'm going to skip the warm-up video and go right into energy. All right. So energy is essential, of course, for meeting human needs and wants. We've got all kinds of different sources of energy that we currently use. There's non-renewables, there's renewables, there's oil, gas, solar, geothermal, natural gas. So many options. Today we're going to discuss how these things are used in order to actually create electricity, what electricity even is, right? Energy is paramount to increasing our life expectancy, making our lives more exciting. Of course, I don't have to tell you. You're watching me on a screen, right? That requires electricity. Over time, people have used much more energy. Today, each person uses more than 100 times the energy the early humans used, and therefore we need better and more efficient ways to produce it. So let's see how we go about that. Now, this is a chart detailing various sectors of energy production that are around today. So we have coal, oil, gas really dominating, as you can tell. And then at the top, you see those 3 little or 4 little or 5 little kind of areas. Those are your renewables, your solar, your wind, hydropower, nuclear, all kinds of things that we hear a lot of talk about, but actually make up a very, very small amount of our grid at the moment. So we're hoping to soon move more away from those 3 big ones you see, and more towards those ones at the top, but so far no dice. So today we're going to take a look at how the traditional methods, the 3 you see there, primarily work, what burning fossil fuels even accomplishes, why do we need to burn them in order to make electricity, and ultimately we're not going to really take a hard look at how solar cells work. It's a little outside the scope of the class, but I highly recommend you look into it on your own, as it's a very fascinating process. All right, this is farther breaking down the renewables. So modern renewables, very, very small amount, as you can tell, roughly 10%. And then fossil fuels take up about 80%. And then we have a little bit of nuclear and traditional biomass. All right, ignore that. So before we discuss more about how electricity is made, let's take a step back and discuss energy in general. Energy comes in 6 primary forms. You have nuclear, mechanical, radiant, thermal, chemical, and electrical. Now, the process of making electricity is a little misleading. You're not making anything really, right? Energy, as we know, can't be created or destroyed, much like matter. All we can do is change forms. So really what we're going to be doing is we're going to take some kind of stored up energy in one of these other forms, and we're going to convert it into electrical. And we're going to lose, quote unquote, some of it to various inefficiencies in the system. It's never going to be a one-to-one conversion, but that is what we are going to be doing. So let's take a look at the 6 primary forms of energy really quick. So mechanical energy is the easiest one. Anything that's moving has mechanical energy. You, right now, have some mechanical energy you're exerting, right? Wind, water, all of those things move. Therefore, they're providing mechanical energy of some kind. And of course, machines we usually think of as the primary examples of mechanical energy. We have radiant energy. Radiant energy is, of course, energy from some kind of wave. It could be a light wave, it could be electromagnetic, The main source of radiant energy is the sun. And we have, of course, cell phones, cell towers, microwaves. All of these things are forms of radiant energy. Chemical energy. Oftentimes, we're talking about potential energy when we talk about chemical energy, and this is anything that's stored in a chemical substance. So a burrito, for instance, is a beautiful example and a delicious one, and it can provide you with a lot of energy if you eat it, and then your body does some things that are, again, outside the scope of this class, but certainly in the wheelhouse of biology, to then convert that energy into something you can use, primarily ATP. But also things like petroleum, natural gas, coal. These things are rich in chemical energy waiting to be released. And that's why they're such good candidates for energy production and why we use them so much. Thermal energy is heat. Not much more to say there. Anything that's hot has thermal energy. Electrical energy, that's the one we're most interested in. Electrons moving along a conductor. A conductor could be anything. Could be you if you get struck by lightning. Hopefully not, though. Could be the air that you see the lightning pass through. It could be wires in your house. It could be any kind of thing. And we are going to be taking a look at how electrons move along these conductors in much greater detail in a future lesson. So let's table this for now and just assume that most likely we want our energy in this form. How do we get there? Well, in order to get there, we need to have some kind of wire, some kind of magnet, and motion. Those are the three ingredients towards making an electric output. Now, your wire is going to need to be a coil. It's going to need to spin inside of a magnetic field. That spinning motion excites the electron and causes electrons, which normally are moving in every direction evenly, and causes them to flow in one specific direction. We call that flow of electrons electricity. Now, there's a lot of very interesting properties that arise as a result, and even the motion of electrons is something we're going to have to discuss in a lot greater detail to really get a handle on, as it's not quite maybe what you're imagining, but that's for a future lesson. In a power plant, we burn something, usually coal, oil, trash, something, to boil water. And then the steam of the water moves a coil of wire around magnets. Now, these coils of wire, as we say, are much larger. They're huge turbines, and they spin really, really, really fast, as we'll see in a video coming up. So it's not quite what this diagram would have you believe. It would be remiss not to mention nuclear energy. Nuclear energy is very powerful. It's not quite renewable, but it goes for much, much longer time than any of the previously mentioned, coal, gas, or oil. We have two kinds we can consider. So, for instance, we could take two atoms and split them, or rather say one atom and split it into two. We call that fission. We could also take two atoms and smash them together into one larger atom. Call this fusion. If you can figure out how fusion works, you can make lots of money. Now, in a power plant, what we do is we take chemical energy that's stored in coal. We heat it up. We create thermal energy. We take the thermal energy and we hook it up to something that spins. Now you have mechanical energy at play, right? That mechanical energy spins a turbine. The turbine spinning excites electrons, and this creates an electric flow. You have electric energy. The electric energy is then transferred along wires, maybe for thousands of miles, until it reaches your light bulb. And your light bulb then converts that electricity into light, which we, of course, refer to as radiant energy. So this transformation from one state to another of energy is really what's causing everything around us to be possible in modern society the way it is. And we're going to continue talking about this. So this is an important diagram to understand. So maybe pause the video here and think about it for a second. Make sure this makes sense to you. Now, we talked a lot about the non-renewables over here, the burning things. Let's talk a little bit about renewables, although as I said, we won't go into huge amounts of detail. So, non-renewables we talked about, but renewables like solar panels. These are up and coming. They have become a lot more efficient recently. So this is Mr. Daney's house. He's another teacher at Walter Johnson. He has solar panels on his roof, which is pretty cool. In fact, he has this little interface where he can look and see how much kilowatt, which is how you would measure electricity in this case, although there's different kinds of measurements we'll talk about in a lot more detail later. And you can see how much he's outputting from his solar panels. That's pretty cool. Another popular way to make energy using renewables would be wind. This uses the same idea as burning something, but now you're spinning a coil using the wind. Pretty cool. All right. Another final point on energy. There's an important distinction between kinetic and potential energies. Potential is something that's inert. It's sitting there, and it can eventually, possibly, release its energy, but at the moment, it's not doing it, like a burrito or a piece of coal. Kinetic energy is something that's moving. Could be you moving, could be something very ethereal, like a photon moving, right? That would be an example of radial energy, but it's kinetic. All right, so any kind of motion, water moving, heat and light moving, all of those things are kinetic energy. All right, so here's another example of the same process we saw earlier. There's a video. I would highly encourage you to watch this video on your own. It is also linked inside your assignment. You need to watch this video. It goes into a lot of detail about various aspects of power generation that it explains much better than I ever could. And then based on the video, you need to answer the following questions. What are the top 3 power sources for global power generation? We already kind of answered that. What 3 ways produce steam that aren't fossil fuels? We mentioned at least 1. What are 2 parts of AC generator? So, or turbine? There's 2. And why do we typically use 3 coils in the stator instead of a different number? And what's the benefit? Now, this last question doesn't have to do with the video. I want you to find some electronic appliance in your house that has this kind of sticker on it. Most of them do. This sticker will tell you 3 things that we're going to explore next time. It'll tell you the volts, the amps, and the hertz. Don't worry so much about what those things mean right now. We'll come back to that and explore it together. I certainly am welcome to look it up though. The volts will have a V at the end, so this is 120 volts. Hertz will have HZ, so this is 50/60. Sometimes it'll be a range. And then for the amps, it'll either say amps or it'll just have an A. So please find something with these, and then we're going to discuss these appliances together next time we meet. Please don't forget to turn in your assignment 1 and start working on assignment 2. Thank you very much for stopping by, and I will see you guys next time. Email me if you have any questions.